Solving quadratic equations, the PQ formula. In fact, we are going to be deriving this formula using a process called completing the square. Now we're going to get started with our conditional equation, x squared plus px plus q is equal to 0. And since it is a conditional equation, we're trying to find the values of x that would make it true. And one way to do this is using the PQ formula, which will help us find the zeros or the roots of this equation. So how do we derive it? Well, let's get started with the equation itself, and we are now going to algebraically manipulate it until we have x equal to some expression made up of the parameters p and q. The first step of this process will be to add negative q to each expression. And what this is going to allow us to do is really focus in on that left expression, to be creative with that left expression. In fact, we're going to rethink that left expression as an area of a rectangle. And let me go ahead and visualize that for you. So we have x squared, which could be visualized as a square with area x squared, and thus it has dimensions x by x. Now that's not the complete area of the rectangle because we still need to include this area of px. So we have this blue rectangle here, which has area px. Now we already know the width dimension is x, which means the length of this blue rectangle needs to be p. Now algebraically, what we want to be able to do is manipulate that left expression such that it is two factors that are exactly the same. And to do this geometrically, I need to transform this rectangular object into a square object. So how do we do that? Well, let's rethink about this area px. Let's get creative so that we can think about this rectangle as a square. So the first thing we're going to do is we're going to divide that area of px into two equal pieces. That means that the lengths of each of these pieces will now be p divided by 2. And consequently, the areas of each of those pieces will now be p over 2x. Well, why would we do this? Well, we're going to be even more creative. We are going to cut off this right piece. And, well, where does it go? Well, we are going to move it. Remember, one of the dimensions of that blue square that we just cut was x. So I'm going to move it on top of our square, which has area x squared. And now you can see that we are so close to have created an object of type square, but there's something missing. There is a piece in that upper right hand corner that we need so that we can find the area of a square. So what we're going to do now is add that piece. We are going to add a piece with area p over 2 quantity squared, because now we have a geometric object which is a square. So I need to add that p over 2 quantity squared to that left expression, to the area of my rectangle. Now there's a consequence of doing that because it changes the value of the left expression. So I also need to add that value of p over 2 squared to the right expression. So you might be thinking that we do not seem any closer towards our goal of having x isolated in the left expression, but we can now think of an alternative form of that left expression. Remember, it's representing the area of this square, and another way to interpret the area of this square is as a product of two factors. In fact, the first factor is made up of that length x plus p over 2. And that second factor has length x plus p over 2. This is really why we want that square, because that product of those two factors of x plus p over 2 can be expressed as a power. And notice that the value of x that we're trying to isolate is now embedded within the base of the power that we're now going to try and extract out. So how can we do this? Well, we are going to take the principal square root of each expression. We have to be really careful now because that left expression, the square root of x plus p over 2 quantity squared, is a little tricky to deal with. Remember, the principal square root of a squared value is the same as the absolute value function. So what we're going to need to do is express that argument of x plus p over 2 of the squared function and represent that as the argument of the absolute value function. And that's important because the absolute value of x plus p over 2 ensures that whatever the input is, it will always be positive. And that means we need to consider two cases. We need to consider the positive case and the negative case. We need to consider when x plus p over 2 is positive, and we need to consider when x plus p over 2 is negative. And let's just go ahead and briefly review this. So we have the absolute value of x, and this function is able to think on its own, essentially. Because if the value of x is greater than or equal to 0, then the function is going to return x. That's what it does. However, if the value of x, or the value of the argument, if it's negative, how does it make it positive? Well, it has to negate that input. So if you negate a negative input, it becomes positive. And that's how the absolute value function ensures that its output is always positive. Now for us, our input is x plus p over 2. And that's going to give us two cases. The first case where we have x plus p over 2 being positive. And then we have our second case where our x plus p over 2 is going to be negative. And all that we have left to do is algebraically solve for x for both of these cases. Let's take a look at case 1. What we need to do here is add negative p over 2 to each expression. And there we have it. We have x is equal to negative p over 2 plus the principal square root of p over 2 quantity squared minus q. Now for case 2, we're going to need an extra step. First, we're going to negate each expression, which will leave us with x plus p over 2 in the left expression. And then we are going to add negative p over 2 to each expression, leaving us with x is equal to negative p over 2 minus the principal square root of p over 2 quantity squared minus q. And we have our two cases, our two values of x that will make this conditional equation true. And in fact, we can now summarize both of these cases using the PQ formula. X is equal to negative p over 2, two cases, plus or minus the principal square root of p over 2 quantity squared minus q. My name is Mark, and thank you for watching.